Factors such as aging, poor environmental conditions, pest damage, and destruction caused by humans gradually leads to the decline of trees around us and may result in public safety and tree health management issues. Hence, it is necessary to carefully assess the conditions of trees in order to provide references for authorities to follow when implementing tree management measures. The basic principle of examining a tree is to avoid physically damaging the tree and its structures. Thus, it is necessary to use non-destructive techniques to evaluate a tree's conditions. At present, the non-destructive techniques adopted for the tree hazard assessment are the Visual Tree Assessment, VTA, and Japanese tree doctor systems, which have been gradually adapted into a comprehensive non-destructive tree hazard assessment system especially tailored to the unique conditions and characteristics of trees in Taiwan. When evaluating a tree, in order to understand the reasons behind a decline in health, we must first diagnose and determine the tree's exterior appearance. The tree crown, trunk, above-ground roots, and environmental conditions must be visually inspected to determine if the tree's overall health is compromised. For example, are the foliage and branches of the crown dense and intact? Is the tree healing well after pruning? Is the exterior shape and cross-section of the tree trunk normal? Is the trunk decayed and/or hollow? Are the roots growing normally? Are the roots decaying in any way? Are the environmental conditions hazardous to the above-ground parts and roots of the tree, or have they become a restriction factor? Are there any pests, pathogenic microorganisms, insects, fungi and/or mushrooms, or other epiphytes found on the tree? Because observation of the tree trunk's appearance is subjective, the use of a health assessment diagram of external tree appearances to determine proper tree health ratings is recommended if necessary. If the preliminary VTA diagnosis indicates that the main hazard to the tree lies with its trunk, it will be necessary to further inspect the trunk. This can be accomplished by using non-destructive testing instruments. To understand the important operating procedures of using these instruments, we use this tree as an example. Firstly, select a height location on the trunk for inspection. This will usually be the cross-section of the tree trunk with the greatest amount of hazardous defects as determined by the diagnosis of tree appearance. The examination procedures are: first, use an ultrasonic wave or stress wave timer to examine the selected area of the trunk and measure the transverse and longitudinal travel time of the cross-sections in different orientations. The smaller the travel time, the sounder the material. The greater the value, the worse the material. These results can provide an immediate preliminary diagnosis of the extent and location of decay in situ. Second, imaging software is used to construct the acoustic velocity 2D tomography of the trunk. Different colors and the corresponding acoustic velocities on the maps indicate the precise extent and location of the decay. Third, a drilling resistance instrument is used to radially drill from bark to pith to obtain the transverse drilling resistance profile. The extent and corresponding locations of decay can then be determined based on the intensities of drilling resistance. The greater the value, the better the material. Health conditions vary from tree to tree. Therefore, the purpose for testing and the actual conditions of individual trees must be taken into consideration, and different non-destructive instruments should be selected accordingly. Lastly, a professional judgment is rendered by combining the collected scientific data from different instruments, including VTA results, ultrasonic wave or stress wave 2D color maps, and drilling resistance profiles, which is then used as a reference for tree hazard management. Research on tree hazard examination remains an ongoing project funded by the Taiwan Forestry Research Institute. For further details, please feel free to contact us.